Hi everyone, welcome back to this channel. It is Edmond here. This is a walkthrough of 2025 S1 summer series. I'll explain the concept behind every question so that you can reach the correct answer. This is question 6. Let's dive in. All right, question 6. Question 6 says that a company produces small bags of flour and large bags of flour. The weight X of the flour in a small bag, so you have to count small bags, are normally distributed with a mean of 502 and standard deviation of 3. So X is normally distributed with a mean of 502 and standard deviation 3. When you write in the normal distribution, you will write the variance, so write like that, standard deviation of 3. Use standardization. That means they're very specific here. You cannot just use your calculator. Use standardization to find this probability. That means that to go and standardize, remember the formula for the standardization, z equals to x minus mu over the standard deviation. That means the probability that x is greater than 508 is going to be the probability that z is greater than, so we standardize it. 508 minus your mean 502 over the standard deviation, which is 3. And this will be the probability that z is greater than 2. So z is greater than 2, as I already said. I prefer to draw the diagram to visualize it. So that means what you're looking for, 2 is on this side. This is standard normal, and the mean is 0. Then you have your standard deviation as over here. So you're looking for the area of greater than what? Greater than 2. You're looking for this. So you go on our tables, but remember the tables will give you this area up to that. So go on your table. I have a piece of the table here. The piece of the table here, we have 2. The 0 of 2 here is 0.99772. That means this probability is 1 minus 0.9772, because the table always gives you this area. So this is the area you have read from the table. That's the area we have read from the table, 0.99772, when this is 2 over here. But you're looking for this. So we do 1 minus that. So our answer, when you subtract, you end up with 0.0228. Next question, you're looking for part 2. I'll change the color here. Let me change the color. Part 2, we have probability between 496 and 508. But when you see this number here, this number is the same as the first one. So we try to see if there's a relationship. Now, if I draw this, and this is I always use the sketches. This is 500 and 508. If you're very keen here, you see that this value was 6 from the mean, which is 502. And this value also is 6 below the mean. That means we have 500 and 496. And the mean here is 500 and what? 502. All these values are the same distance from the mean. It means that the probabilities are going to be the same. That means this probability here is 0.0228. It also means that this probability is the same because there's the same distance. It's going to be 0.0228. So what you're looking for the probability in the middle, which is going to be this probability here in the middle, this probability in the middle. You can do so many things here. So you have visualized it. So you can do so many things here. What I can do, I can just get 1 minus 2 times 0.228. That's the easiest way I can think about it. And then your answer is going to be 0.9544. We move on. Okay, for part C, I will use I will leave this one on. I'll leave them on. So I will do part B down here. All right. Now for part B, they say that you have 4 random samples from the small bags are taken. Find the probability that exactly 2 of these bags contain more than 500 and what? 508 grams of flour. Now we know that the probability that a bag contain more than 508 is 0.0228. So what you're going to do, but you have 4 bags and you want exactly 2. That means we can have 2 out of the 4. That means we can have, I'm going to call it the event of being less than, if we call the event of being less than greater than 500, if we call that event, say, if we call that event P, that means we can have the first bag greater than, the second bag greater than, and then the other 2 bags are less than. We can have that prime is, that means that's the opposite of less than. You can have the first one greater than, the second one is less, the second one is less, and then the fourth one is going to be greater than. So you can see all what you're doing to all what you're going to do to get this probability. You get the probability of succeeding, of getting a bag which is greater than 2 times, and the probability of failing to get that bag be greater than 0.9772 2 times. But this event here, the event can happen in how many ways? It can happen in 4 combination 2 ways, which is going to be 6. It's going to be 6. You can list it and see how it can happen, but the shortcut is 4 combination 2, which is going to be 6. Now you can play this on the calculator and get your probability. Then you see the probability is going to be approximately, it's going to be 0.00297 78. So if you write it 3 second figures, you have 0.0298. All right, it is more of a binomial, but remember, we are not looking at it as a binomial, but this is a tip you can use to get how many possible combinations you can try to rearrange, but the probability is the same. The number of times you can try to rearrange it around. All right, I will erase this and then you go to the next question. All right, next question. I think I'll use the next slide here. So we are saying this information says that y grams, so the weight y grams of the flour in a large bag, now looking at large bags, are normally distributed with a mean of 1024 and standard deviation of sigma. I don't understand deviation. That means y is normally distributed with a mean of 24 and sigma, we don't know sigma, we don't understand deviation. Now, so they've told us that the 80th percentile weight for the flour is 1038.51. Now, I am going to try to sketch it. I always draw it. I've told you I always draw it. So the means on in the middle, which is 1024. Now, the 85th percent, it means that 80% mark. Remember, you're starting from 0 over here. That means that mark should be at this point, and this probability which is left will be 15%, because all of this is 85, and the mark responsible for this 85th percentile is going to be 1038.51. And they're asking us to show that the standard deviation is 14. So what you're going to do, we are going to find the standardized value of this. So you are asking yourself, in order for these guys to get this probability, which was 0.85, they are to standardize this value over here. And how they standardize that value? They use the standardized formula that we have already seen, x minus mu over sigma. So you have x, which is 1038.5 minus mu, which is 1024 over the sigma that we don't know. But we can find the z over here from the table. So we go on the small table. I think I have the small table here. We go on the small table, which is here. It's not showing properly. That means we are looking at this area. We are looking at that area, which is 15%. You go on the small table, and then you find the 15% in the small table. It's not showing properly here. And you find that that Z value for the 15% is 1.0364. So this is the Z value when you standardize this value of 1038. Then you have, this is 1038 minus, I think I have a value for this. We can put a value for this when you subtract. So when you subtract, you have a value for this. I will erase this. You have should be 14.5 1 over sigma. You make sigma the subject, so your sigma is 14.51 over 10364. So your sigma is 14. So the last part here, part D. Part D says that there is a value k such that the probability, I'm going to use a diagram. So that the probability, this probability over here of k to be greater than, for x greater than k, and the probability for y to be less than 2k is the same, is equal to p. So I'm going to do a diagram. So I have, if I consider the x, okay, remember the mean for the x is 502. So if I assume that k is, say, k is greater than the mean, if k is greater than the mean, or maybe I assume k is less than the mean, k is less than the mean, maybe k is over there. I don't know where k is, but whatever position k lies on, I'll get an interpretation. So you're saying probability of greater than k, that means going to be this probability here, which is greater than 50%. So that's probability that x is greater than k. Now, remember, the mean for the y is 1024. So, but let's say the probability of 2k, if this value is over here, of course, 2k is going to be like double that. And if that probability is the same, but this one is less than, y is less than k, that means that 2k values should be on this side. That 2k value should be on that side. That means this should be the probability of y less than 2k, like that. Now, I'll try to understand this more. If I decided, if I thought about this k to be like over here in this region, that maybe you decided k to be like, maybe k lies in that region. That means the area you're looking for greater than, which is that region over there. All right. That means automatically the 2k is going to be in this part over here. The 2k will be here, because in that case region you're looking for will be over there. That means it will be small area. That region over there is equal to that region. So that's how the reason it out. So it doesn't matter where you see your k, which side your k lies on, but all the same, as long as you remember the probability of greater than k and probability of less than 2k, they are the same, which is equal to what? Which is equal to p. So if this probability is the same, it means that this value, the z value of k and the z value of 2k are going to be the same, but opposite, because the area is the same. I guess that makes sense. The area is the same, so it's going to be different. I've already congested my diagram here. I'll do this diagram again when it's not congested. So I'll do it again over here. We are saying that if the k, we are putting our k over here, and this area here is p, okay, and this is for the x, and for the y, I've done the same thing, and you say in this case our k is, this is 2k, and this area over here is also what? Is also p. It means that if that's the case, these areas are the same. That means the z value of the k here and the z value of 2k here, they are going to be the same. So how do you get the z value of the x? Remember the standardization, z is equal to x minus mu over what? Over sigma. So for x, your z value will be equal to the x value, which is the k, minus the mu, which is 500 and what? 502 over the standard deviation, which the standard deviation is what? Is 3. And for your y, when you standardize this, you're going to have your z as your y, which is 2k, minus your mean, which is 104, over the standard deviation, which you have just found out to be 14. But on the diagram, when you look at the diagram carefully here, when you look at the diagram, you see that for this k will be on the left. That means the z value is going to be a negative, and this k is going to be on the side, so the z value will be a positive value. But at the end of the day, they are equal. So what I'm going to do, I'm going to say that this z value over here, so the z value of the x, which is k minus 502 over 3, is equal to the negative value, or the negative side, whatever I put the negative, they are going to be the same, but opposite. So the z value of this negative of that, we'll put a negative over here. The negative on the x is equal to 2k minus 1024 over 14. Now here you're just going to solve the equation. So solve the equation. Now this is algebra. You can pause the video and try to do it. So this is negative, this is 14 into k minus 502 equals 3 into 2k minus 1024. Then you guys can do the solving because this is algebra. I think you can do it. So when you do the algebra here, you end up with minus 14k plus 7028 equals to 6k minus 3072, and then you collect the like terms, you end up with 20k as equal to that, and then you end up with your k as 505. That's your k value. That's the first part of question D. The next part, the last part, they're asking us to find P now. P is the probability, so you can use whichever one you want to use. So you have the value of K here now. So the value of K is 505. So you're just getting the probability that X is greater than 500 and what? 505. So you're going to come here. Now you can see from our assumption, our K is 505, and we know the mean value here we're talking about is 502. That means on our assumption, actually the k value is on this side because the mean 502. The k value is actually over here, 505, because the mean is 502. But you can see our assumption doesn't matter, even if in the drawing we do it on this side, but the value is over this side. So we're looking for k greater than this. So you do exactly the same the way you did the first question. You standardize it. This is the probability that z is greater than 505 minus 500 and the mean was 502 over 3. So this probability that z is greater than 1. Then you're going to go on the tables. So you're going to have 1 minus probability of less than 1 from your table, probability of less than 1. Check your tables, which will be 0.8413, and your final answer will be P as 0.15887. Like that. Thank you. That's your value of P. That's the end of this question.